Hello, everyone. Thank you for coming. My name is Enthusiast, and I am the owner of German System Windows. We are a family-based, family-owned company, and we deal with custom European windows and doors. We are very excited to host this event and to have Rowan as our speaker. Rowan is an architect based in Portland, Maine, and he specializes in high-end residential design. After a decade working in New York, he divides his time between work at Briburn in Michigan, where he is having a very great time building a house. Through this event, we want more people to understand why energy efficiency is so important and discover the world of high-performance house building. But I'll let Rowan dive into it. Let's welcome Rowan.
Thanks, Hortensia. Can everyone hear me okay? Great. Okay, I'm Rowan. I'm an architect. Hortensia said I work in Maine mostly, but I'm building a house here in Michigan, and here I am to talk to you about what I do every day. I work at a little firm that is deeply committed to this stuff, and we self-select for our clients. They come to us and they say, we want what you do. And we think this is great because we know what we do, we live in it every day, and we're finding increasingly, the more we get into the design process with all of our clients, that their definition of what we do is usually completely different from what we think it is. So we're in the middle of a internal rethinking about how we talk about who we are and what we do. And this is a little insight for all of you about what that thinking is, where we are, what it is we think we do, why we think it's important. So hands up, anyone here who lives in a house? Great, this talk is for you. We mostly design houses, not entirely, but it's probably the majority of our work. And right now, the residential sector is really driving new ideas in the industry. What we are pushing in terms of how buildings work for the people inside them, it is happening in the residential market and then being pushed out into other markets. It's a great time to be a residential designer. So what we're going to talk about today is this term high-performance building, what it means, and what it is turning into, what I think it's turning into over the next few years. And probably best to think about this as like if you were a scientist, when you're starting a paper, first thing you do is define your terms. So a lot of what we're going to be doing today is talking about words, what they mean, why we use them. I'll try and make it interesting because I know definitions are normally fairly dry. It's not going to be a dictionary thing, I promise. So this is the kind of building that we build. Houses mostly made of local materials. Sometimes they have green roofs. They have lots of natural light. They're very comfortable. They don't leak. This is not the same house. Most of our houses tend to look the same way. We have a style. It's part of why our clients come to us expecting to know what it is that they're going to get. And then we start using terms like high performance building and energy efficiency, and it all starts to get a little shaky. So we sat down together as an office to start to write out some of the terms that we thought were important, critical to what it is that we do. This is a small selection. There is hella jargon going on behind the scenes in most architects' offices. Hands up who's familiar with all of these terms. Yeah, I thought so. And yet, here we are in our little office sat together. Every one of us has a strong opinion, several strong opinions probably about each of these things. And so when we bring outsiders in and don't explain what it is, you end up with a kind of impenetrable soup of acronyms and specialized phrases that are quite tough to get your head around. So what we're going to try and do today is begin to bring some order to all of this stuff so that you guys can have some insight into how it works. There are a handful of big container phrases, like to describe what the thing is in totality. Most of these words are quite specific things, but a few of them are big. So we asked ourselves, are we green building architects? My boss is the principal's previous firm was with the Green Design Studio, and he is absolutely adamant that green as a useful term in design died around 2008, that it had both got too trendy, but also too associated with slightly hippie-looking buildings to be useful anymore. He refuses to let us use it on any literature we put out there. Sustainability is going through a slightly similar thing right now, where you probably noticed that it is used in almost every newspaper article at some point. Everything, every product declares that it is in some way sustainable, reaching a moment where it's so widely used that it's kind of not useful anymore. Another really popular one is building science. A lot of people I know describe themselves as building scientists. This is a special kind of nerd who deals with construction, and it is often used as a job title. People who will come and see what's wrong with your house if there is a smell that you can't get rid of. And for us, it's a little too specific because we're also designers, and I want to call myself a poet, and a building scientist and a poet, definitely not the same thing. So we land on this phrase, high performance building, which right now is in vogue because it is just the right mix of very specific and cool sounding, but also sort of vague enough to kind of capture a whole big, broad spectrum of things. So those first three all started to get used around the time that the energy crisis hit in the 70s. And all of a sudden, it cost an enormous amount to heat your house. And we didn't like that, so the building profession rushed en masse to try and solve this problem, as did politicians. And here's Jimmy Carter with the famous solar panels on top of the White House, which I didn't check before I came here. So I assume that that went great and the problem was solved. No? Okay, so still a problem. Good. But the fourth term, high performance building, is much, much newer. And it's definitely different from that kind of sandal wearing, yurt construction, green building vibe. That phrase has got a little bit of a high performance building. It's definitely not that. You know, it's something athletic and precision and possibly slightly illegal at times. And it was developed and became more formally used in the early 2000s. So, okay, little guessing game now. Three people who might have been in the lead of the organization who developed the term high performance building. A, William McDonough, well-known green architect and author of the book Cradle to Cradle. The Wolfgang Feist, founder of the Passive House Institute in Germany. Or Donald Rumsfeld, Secretary of Defense. Okay, A's, who reckons it's A? B? Okay, B. C? No C's, shame. So the phrase was actually developed as part of a DoD exercise in the early 2000s to standardize how their buildings were built, mostly pushed by the Army Corps of Engineers. I suspect Rummy didn't have much to do with it, but it became part of something that's still available, the Whole Building Design Guide, which is a fantastic resource. I apologize for the terrible low-res image. Best the government can give us these days, I guess. It's an online network of articles and resources that is tailored for government procurement of construction, but free access to everybody. It's a mix of really, really good technical information and incredible levels of greenwashing by corporate government pork stuff. And the way they define high performance building is with lots of little diagrams like this and words like sustainable and secure and functional and accessible and productive and historic. Aesthetics also, and there's dozens of articles that they'll provide explaining how they think that works. We find that by the time we've used maybe 2 of these words, we've got more questions than we have answers. And so we've come up with our own slightly more straightforward, broad definition, which is that there's building really good buildings and there's high performance buildings, and they're basically the same thing. If it's a good idea and it makes your building better, it's probably something that is incorporated in high performance building. And so all of those ridiculous words that we saw in the soup at the beginning, we can start to organize into things that are about good and bad buildings. There are things that are problems. We all know when the wind blows through your house and all of the heat is sucked out with it. We know when your house has water running down its walls or mold problems because there's a hole in the roof, that is a problem. We know when you find yourself getting real sick in one particular house, that there is something wrong with that house. We all know too painfully what happens when the energy bill doubles year on year and your wages don't double to match. We know what happens when your kids start coughing in their bedrooms. And those are sort of broadly the biggest problems that high performance building is aiming to tackle. We also have some subsidiary problems that everybody kept bringing up that we are also, I mean, fundamentally underneath or hiding under all of it is we are trying to do something about that. Then there's a whole series of measurement techniques that we've developed over the decades, some of which you'll be familiar with. If you go to Home Depot, it is required that insulation has its R value, which is the measurement of how much it stops heat flowing through it, written on the outside of it. So you go in, there's a big bag of fiberglass and it says R15 on it, and that means that whatever an R is, it's stopping that much, more is better. We have requirements for stopping your warm air leaking out of your building, and even have measurements for that. Has anyone ever seen a blower door test? Yeah, we've got some nods. Okay, so this is where it gets into the building science stuff. It's incredibly sophisticated, complicated, difficult thing, right? So what they do is they close the windows, they put a bit of plastic over your front door and a large fan. You've seen this, okay? Yeah, great. Great, yeah. It's pretty cool. And they turn the fan on and basically they get up to a certain level of pressure in the house and they see how much it leaks out. And the more air leaks out, the more air is leaking out of your house at lower pressures. And with each cubic foot of air that heads out, some of your heating dollars are also leaking out. We're also in the business of putting together little computer models of how all of that comes together, of how much you can expect increasing insulation airtightness to help stop all of your energy leaking out. And there are all kinds of very standard builder techniques for achieving those measures. There's a secondary group of measurements that high performance building is starting to shift into. We've been completely focused on energy efficiency. And that is, your house is built, how big are your heating bills? essentially, or cooling bills if you're in Florida. But increasingly, we're realizing that the construction methods and materials themselves are a huge, huge deal. I'll get onto that a little later. We then have a set of standards that people can start to adhere to. Some people have to. The most familiar one will be the energy code, because it's part of the building codes here. And that sets levels of insulation and airtightness you have to have in your house. When you build a new home, you have to put a certain amount of insulation in the walls and in the ceilings. That is codified by the government and required in every state. Each state can adopt a different set of standards, but they all do have them. And then there's a series of optional things that are becoming more and more popular. LEED was one of the first. This is leadership. I'm going to get it wrong, so I'm not going to say what it stands for. But it's a checklist where you get certification. The more good stuff you add. Add some solar panels, get some points, keep adding good things, get to a gold standard, stick a little plaque on your wall. Net zero is a target of making the energy use of the building match the energy the building produces for itself. So typically, solar panels is the obvious way to do it, where you're trying to use no more energy than you produce. When that gets balanced, you are at net zero energy. And that's a pretty popular standard. There are net zero homes in Michigan. There are also a couple of passive houses in Michigan. This is nothing to do with passive aggression. It's a German created standard that aims to reduce the energy use of a building through a handful of really, really simple mechanisms. Now, there's definitely a bit of this going on, where you start off with one standard, it's not good enough, so we make another one, and then someone else comes and says, oh, these two standards are definitely ridiculous. Why not make a universal standard? Now you have three standards. Someone else comes along, says, well, these three standards don't cover everything. Let's make a fourth, more universal standard. And now we have all of these different acronyms and tools and ways of achieving good building. But one has kind of one, and that's passive house, because it's incredibly simple at its core. It really only requires a handful of things. It needs good insulation around the whole building. It needs a series of materials or layers or whatever that makes the building airtight so that air isn't leaking out. To make up for that air, mechanical ventilation. And they want you to pay extra attention with Swiss German efficiency to the places where bits of the building that aren't insulating, like metal structural beams, are covered up with insulation so that they're not channels for heat to leak out. And they get an extra little bit because windows and doors, there are great windows and there are terrible windows. All windows are bad walls. No window is ever going to insulate your house as well as a wall would. Obviously, you need daylight, you need ventilation. We have to have windows. Windows are nice. So we pay special attention to the windows and end up with crazy things like this because they're such critical points in that little box. And that's kind of it. That's how passive house works. And it is now pretty much the core of American energy code. Every single house in this country is built not quite to the stringent levels of this stuff required to meet passive house certification standard, but you have to have tons of insulation in your roof. You have to do a certain level of air sealing. If you do code required level of air sealing, you're also now required to have some mechanical ventilation of some kind. Those requirements at the moment are pretty low, but they are required. And they're getting stricter every year. Maine is at a slightly more northerly climate zone. In the north of Maine now, you can't build walls that just have insulation between the studs. You have to have continuous insulation. It's causing builders to freak out slightly because it involves some slightly different building techniques, but it's coming. We will be here in Michigan before the year is out. Sorry, the decade is out, I'm pretty sure. And where are we? And these houses can kind of look like anything. I've picked a nice modern house in the Pacific Northwest because they have some, I'm not selling the architects particularly, but they have some great photos I'm going to show you later of some important bits. But when I worked in New York, I was working on neoclassical mansions for the fabulously wealthy who generally couldn't give a rat's bottom about climate change. But they really wanted nice, comfortable houses, and the techniques are almost identical. Here's why Passive House is becoming the kind of bracket standard behind the scenes. Because if you want to reach net zero, this gray bar is how much energy a house, 2,000 square foot house, standard national house, uses every year. This is how much solar power generation you might get off a third of its roof. And that's the difference between the two. So if you want to get to a point where you're not using more energy than you can create on your house without going crazy, you have to start cutting the energy that the building uses. And the best way to do that, cutting your heating and cooling, because that's the bulk of the power the building uses. How does it happen under the skin when people are designing this stuff? We're using ridiculously complicated bits of software. This is a program called Woofy, developed by Passive House US, that requires you to make dinky little models of your buildings, and then we plug in all of the components that it's built out of, and then this person did a great job. This is from the Passive House website. So obviously all of these are green checks, but it gives you big red crosses if you are using too much heating or too much cooling. So it's telling you how much energy is getting through each of these windows. Is it too much? Is it too little? How much is leaking out? Too much? Too little? Where can you help? Where can you hinder? And what our models tell us is all trending in the same direction. This is a little excerpt from the Michigan Energy Code. These are minimum requirements for new construction or major remodels. There is an amount, these are R values, an amount of insulation you have to have. R49 is about 16 inches of loose fill cellulose in your attic. That's a minimum now. And you start to see the 20 is the R value you can have in a framed wall. It's bigger than 2x4. It's at least a 2x6. And the 13, which fits in a 2x4, has to come with 5, and that 5H is continuous, has to be unbroken by your structure. That's a Passive House thing, and it's in the Energy Code. And that Energy Code is from 2015. And we'll be moving on to a new one at some point, and it'll start to, because it's happening in Maine, these will start to get more stringent. But what does that mean? It's pretty simple stuff, mostly, you know. Here is somebody wearing some really nice clothes for the job she seems to be doing, but blowing loose fill cellulose into their attic. You know, these, we need to talk about the ducts, but in it goes, and that stuff's cheap and easy. Everyone knows how to do it. We make it here in Michigan. It means nicer windows. No, Tenzia sells them. Window technology has moved on massively in Europe, and it hasn't moved on quite as far in America. And I'm building a house here in Jackson, and the building officials were on my backside about my windows, and they came to my house specially to give me a little sheet about all of the requirements that they had to meet. And I looked, I'm used to dealing with these things. I looked at them and I just couldn't believe that anyone is still selling things that performed as badly as the minimum requirements that they were but they were really fussy about it. So it means that somebody somewhere is selling lots of windows that don't even meet our minimum energy codes, which aren't that strict right now. Now, this thing exceeds the insulating requirements of the energy code by about 3 times. So who's making something worse? I don't get it. I won't talk about Windows too much because it's a whole thing in itself, but this is an example of the kind of drawings we do for our windows. And some of it is designy stuff about how it looks and how this is a section through the head of the window, how the flashing is supposed to come down, what kind of trim goes on the inside and the outside. But at least half of the notes are about air sealing. So that blue line down there is a waterproofing membrane. The red line on the inside is the modern version of those polyethylene barriers that we used to put on the inside of walls. And we talk a lot about how to seal them around the edges, because the place where your house loses the most energy is through gaps where the air can leak out. So where windows meet walls, we spend all of our focus. And this is, I couldn't resist, a bit of product placement for Sieger, who are a Swiss manufacturer of these new high-performance membranes and tapes, and the tapes are incredible. I put this up because all of their installation photos feature this gentleman who wears a waistcoat while he works. My experience of it is more like this. But again, it's just sheets of stuff and tapes and bits of wood, and occasionally, when I really have to, a little spray foam thing. And those 2 biggest things, the insulation and the air sealing, forms the vast majority of all of the efforts that have been put in by the community that probably by now call themselves high-performance builders. But there's a new one. This is a book I owned as an undergraduate because I was one of the cool party kids. And it is published by the German Passive House Institute. It's bilingual. It didn't teach me any German. But it's a huge sort of glossary of how to build different walls, different floors, different roofs, how to join them together in really clever ways that make sure all of the structure is overlapped with insulation. You sort of see in this one, they've got some continuous wood fibery stuff on the outside. You've got some kind of clever truss system with insulation in the middle going on. But there was this little bit in the corner. Couldn't get anyone to talk about back in the early 2000s. These little colored graphs of what materials were in those assemblies and the ecological impact of getting those materials into the buildings. And I don't really know what they meant at the time, mostly because it was all in German and no one seemed interested. But it is the hottest topic at the moment, to the point where at the Northeast Sustainable Energy Conference that I was at in Boston this year, it was featured in almost every talk, and it has become the conversation of the moment. Started at NESI in 2019. The keynote presentation showed this chart, and everybody lost their ever-loving minds, because what we've been focused on, what science nerds are calling operational carbon, but is basically the energy use of the house, but calculated as the equivalent amount of pollution going into the atmosphere. If that's how much over 30 years our buildings are using or putting into the atmosphere in their daily use, that was how much the construction materials of those buildings were putting in to make them happen in the first place. And if we were only thinking about this, and we had only been thinking about this, we've been ignoring half of the problem. And so what everyone's doing these days is life cycle analysis of all of their materials, which starts with how they're grown or mined or whatever it is, how they get to wherever they're processed, how are they processed, how do they get to the site, how are they installed at the site, what happens when they die. And that thing we've been so focused on that when we talk to most of our clients about what we do, they think it is that we do that saving, reducing, making more efficient the operation of the building is a small part of a much bigger picture. Why does it matter so much right now? Well, the planet does seem to be having some issues at the moment with the amount of carbon in the atmosphere, regardless of whether you think it's caused by human activity or not. In the construction industry, there's no doubt we're definitely doing that. It's about a quarter of global emissions from the construction industry, and that embodied or the energy in the building materials happens right at the beginning. It's happening right now, and the use energy happens in small amounts over a long, long time. So in that first year of your house being built, almost all of the pollution you put in the atmosphere is in the materials. And it's all well and good saying we have an efficient building that over 50 years doesn't use much energy if in 50 years everything looks like those Australian wildfires from a few years ago. So the new tool is an environmental product declaration. Hands up who has seen one of these before, heard about them. Good, you shouldn't. No one should look at these. They're impenetrable. It's pages and pages of this stuff. Now, what is the ozone depletion potential of a Vantec floor sheathing measured in kilograms of CFC 11 equivalent on stages A1 to A3, 5.1 e to the -7. What does that mean? Luckily, people are putting together tools that take this data and turn it into stuff you can use. The big kids in large commercial firms are making enormous, complicated models of their buildings in the computers and spitting out all kinds of data. This is from a program called Tally. But for us poor folks in the residential world who don't have whole teams of energy efficiency people, or people who are just building or who are just homeowners, there's a great new tool called Beam that Builders for Climate Action have released for free. It's basically a large spreadsheet, big database of dozens and dozens, hundreds of building materials. And it tells you, you type in, you say, well, I've got about 3,000 square feet of walls in my house. If I spray foamed it, how many kilograms of CO2 would I be putting in the atmosphere? And the answer is, whoa, tons. That's a lot. Which is why the spray foam industry has been changing its blowing agents. And now new spray foam, much, much less. But compared to nicer insulations, cellulose actually stores carbon dioxide because it would otherwise be rotting, or newspapers burning them probably. And Beam gives you this nice little breakdown of where all the bad stuff in your buildings is. And so this is really a thing for people who are doing big renovations and new buildings. But whenever we're asked, okay, well, what's the problem? Where does this stuff go? The answer is really, really clear. This is a standard 2,000 square foot house built with 2x6 walls with a full basement, 2-story thing, 3-bedroom house maybe. It's all in the foundation. Concrete is by far the worst offender for just polluting everything. So we are trying to persuade our clients not to build basements, which you can imagine is a really interesting design challenge. But there are lots and lots of things that we can do just with really, really simple product choices. The difference between putting 4,000 kilos of CO2, and to put that into perspective, driving your car every day all year puts out about 2,000 kilograms of CO2 equivalent. So just in building your walls, you're talking about driving your car constantly for several years, and cars are among the most polluting things we have. This model looked at swapping out a fiberglass insulated wall with a layer of foam on the outside for a double framed wall filled with cellulose. And the difference was stark. Almost a decade worth of driving your car of carbon equivalent pollution in the atmosphere will be saved just by switching from fiberglass and foam to cellulose. Insulation is one of the easier places. Yes, question. Our values staying constant. One of the clever things about Beam is that it lets you decide, and it doesn't let you decide by thickness, you decide by R value. So you're targeting a particular amount. Where are we? Why does it matter? Even if you aren't involved in any kind of building, even if you don't believe in anthropogenic climate change, this graph shows the amount of CO2 in the atmosphere over the last couple of hundred years. It is nearly double now, which means the air we're all breathing is less fresh than it was. So any activity that we take that puts this stuff into the atmosphere is going to get us to a point. And the CO2 detector in our little room, yes, question.
Cinder blocks, is that less carbon emissions than concrete?
Great question. So the silly answer is you should download Beam and take a look. It's loads of fun. Yes, I will follow this up with a little cheat sheet with lots of links. But if you go to the Builders for Climate Action website, there's a sign up for Beam. Short answer, no, it's not better. Most concrete block requires just as much energy to make as poured concrete. They usually come out about a wash. Of course. So what we're learning as we look through this is, to the surprise of absolutely nobody, that we're back to another really simple no-brainer situation, which is that materials that seem like they would be healthy and nice, like hemp fibers and recycled newspaper, are way better for you and for the planet than materials that are really stinky. So I know we've got some, sorry, before I move on. So this is the lesson. This is that house we looked at the beginning with the big square boxes, nice big glass that I said we were going to look at again. This is its foundation. And this is what is making high performance designers cry around the country. This house is beautifully built. From a technical perspective, it is amazing. It is so well insulated. It is never going to leak. It is incredibly detailed, wonderful. But that was achieved with massive amounts of concrete, and it has an R60 basement slab that they achieved with, this is styrofoam. It's like that thick. And the amount of carbon that went into that, we go back to this graph, that went into that to get the really energy efficient lifetime use. That building may be paying that off for most of its lifetime. It may never break even on that energy use. So I know we've got some interiors people. We're here, Michigan Design Center, mostly interiors stuff. This is where it gets interesting for you guys, where we're just beginning to get our toes wet. A lot of the materials that are really bad for the planet are definitely really bad for people too. There's an almost one-to-one relationship. And so this is a safety data sheet. Who's familiar with safety data sheets? Yeah. So most products and OSHA requires anything that might conceivably be harmful to provide a safety data sheet. And it basically is like an ingredients list. This is the pizzas I used to eat from Tesco's. And I think everyone is becoming familiar with the idea of ultra-processed food being a little bit challenging for our bodies, and ingredients lists like this, including several acronyms with no explanation, and propyl gallate, stuff you have to look up, right? But that's a real red flag for the quality of the food. Exactly the same thing is true of building materials. This is the good spray foam. We specify this stuff. It's the nicest stuff you can get. There are a few different brands, but spray foam that is less toxic, has nicer materials. The blowing agents don't destroy the ozone layer in the same way. And here on its safety data sheet, it says hazard statements: damages fertility and the unborn child, kills babies. And it has to be installed by people in hazmat suits, and you have to leave the house uninhabited for 3 days after that product has been installed. And that's after all of the lobbying done by the spray foam industry to make sure that that wasn't a longer period, because you can imagine that the people testing its level of hazardousness wanted that to be a lot longer. And this is true of the stuff that architects are specifying. It's definitely true of the stuff that decorators and interior designers are specifying too. And so a lot of this is a little bit from our insulation spec, and we are telling our contractors what we pre-approve, which kinds of insulations are okay. There's a little bit later on in bold that says spray foam is banned, XPS is banned, except in approved circumstances. And as designers, specifiers, decorators, anyone who is helping anyone else choose, or if you're choosing it for yourself, just homeowners, it is on us now to start to pay attention to these things. So at the moment, you don't always have to look at stuff like safety data sheets. Like obviously, if someone gives you an ingredients list that says kills your babies, that's a warning sign. But sometimes it can be as simple as a smell test. If you walk into a furniture showroom and it smells bad, that's probably because those sofas are off-gassing chemicals that you probably shouldn't be breathing in. And I had thought, because I'm from Europe where there are lots of rules about things, that it engenders in you a kind of laissez-faire approach to how poisonous the stuff in your house is. And I had assumed that things like formaldehyde would probably be banned from building products. But formaldehyde is in almost all plywood, almost all oriented strand board. If you are buying kitchen cabinets, there is a really high chance there is a dangerous level of formaldehyde in those cabinets. And so it is on us as people who are selecting these things and selling these things to check that, to ask for these things. And where there are red flags, say, why is this here? Because a lot of the time, it's not for the consumer. It's because it makes the thing, a lot of this stuff is not to make it taste nice or be good and healthy for you. It's because it, keeps the sausage crumbles looking nice and juicy in the package, and so that it lasts longer in the package. So this stuff, every time we talk about it, is really, really critical. And the other thing we can do is more stuff like this. This is our little group in Maine. We meet there's a little store just like Hortensia's that sells high performance European windows. We meet every month and we talk about stuff like this, because sharing this kind of information and getting it out there is the most effective way of getting change to happen and getting beautiful buildings built. This is building that some friends of ours just finished in Maine. It is built entirely out of compressed straw bales and clay plaster. And that's it. Thanks, everyone.